Yeah, basically, this information is in manual. So very like few points are not covered there.
But this mesh is generated with X mesh.
Right. Yeah, it's a internal measure. So this is the main how you guide to make SPECFEM to make the internal mesh. Yes.
Only you specify the number of elements in each direction on the
surface? Yeah, it's there.
So
it's here, right?
Within these elements, earlier you were talking about like LGL points. Those 5 or 7 points are inside each of these elements.
Right. I think there is only one option: 5 GLL points per element in this package.
For the internal mesh.
Well, for the it's I think it was found that this is nice. Like it can be more, but it's okay to have 5. It's already fine. It's enough. So all SPECFEM package, I think, built with this way. You have 5 GLL points, and you are right. You have 48 elements multiplied by 5 GLL points in each element.
5 in each direction.
Yes. So you have this number of points.
But we don't have to specify number of GLL points.
No. It's 5 by. So this is the main the par file for to guide SPECFEM and build the mesh. Here's, as I said, as you can see, it's very simple mesh, but it can handle more complex mesh as well. Now one thing we need to make if you want to output the files of the mesh for visualization, we can put VTK files to true. It's also in the instruction. So turning this line to true, this will generate VTK files. You can open them in Paraview and see the mesh. Basically, these figures were obtained from the Paraview, from VTK. This is a VTK files. Yes. So the example designed to work with the 16 cores. Yeah, as I didn't try to make it work on the virtual machine. It will like 99% will not work, and as others pointed out. So the idea is now I'll run this line by line on that cluster I tried on the Peloton, and the output we can look together, or you have the output as well in the folders actually. So you have that.
But in practice, if I get those numbers of processors wrong, then it'll interaction.
Sorry, say again, please. Oh, so right, that's the way you want to build the kind of the dimension of the elements more or less equal in each direction. You don't want to squeeze elements, or it's not good. So you define number of elements in each direction first, given the frequency range you want to resolve, and then you'll have an idea of how many processors based on the system. Let's say you have 32 cores on the node, so you play accordingly. There was another question? No? So we select this option, VTK to true, and we submit. Now let's submit the job for to build the mesh. So there is a script to do this. So we have, as I said, we have 3 steps here. So there is a script to submit the mesher, generate databases, and to run the solver. So, and there is also one script which can be run to combine all these steps together. But we will go through each step and look one after another. So first is this file, which is in binary, generated by SPECFEM in binary folder. This script will run the SPECFEM3D from the binary folder. So you see we have 16 cores for this, and should be very quick if it works. So just do sbatch and submit this script. So you see the job submitted number, and we can look and see whether it's there. It's not. Okay, the strange thing, there is no output from this step, but it seems that the output was created. Oh, it's here. Now it's shown here. Yeah, so just the job or job ID. So it should be finished now, and we can look at the output information of this step in the output folder, output mesh frame. So this is the output information. Yeah.
For this, we need to be connected to the Peloton, right?
Right.
Do the batch submission.
Right. This is only I'm running this and following the instructions. It will not work on the virtual machine, but you have all output from these results.
We can also
So the information from the output of mesh, just gathering all information, and so we go quickly. What is important here at this stage is the quality of the mesh can be assessed through the ratio of the elements, dimension, size in X and Y direction. It gives you already the information about this time step. It's not exact because the velocity is not like only approximate values of velocity that are given in mesh part file, and SPECFEM will interpolate the values, parameter values on the mesh at the next stage. But there is already time step. Like the idea of the time step you can use in your simulation. You can see it's about 0.0008 seconds. If you can try with the smaller or with a larger time step, but it's highly possible that it will not stable. The simulation will be not stable. And also, so this is based on the current stability CFL condition. It should be below 0.5. And also there is the quality histogram of skewness. You can assess the quality of the mesh, which is really good here because it's not complex. There is no topography and the elements quite simple. So again, we have this suggested time step, and it's done. The mesh is done. We can now visualize it in Paraview So if you install Paraview on your system, you can copy the VTK files from that directory. It should be in results. If you go to output files, there are, so this is the bad thing with the separate traces. You have many, you can see many binary files, so it's not good. So here are the VTK files of the mesh. You can open them in Paraview, as I said. If I type Paraview, you can download this package and install on Mac, or well, it should work at least on Mac machine. So there are free versions of it. And you can open, here we'll open one VTK file from the next step. Directly we'll overlay the mesh with the velocity. So VP VTK, for example. We select that and apply. And here we are. So this is a 3D model, VP model. It didn't finish this step yet, but it's second step. And the mesh is, you can select representation surface with edges here, and you see the mesh. And you can put the coordinates, show axis. So you remember the dimension of the model, quite simple, about 190 by 190 meters by 90 meters and 60 meters in depth, and almost like homogeneous mesh.
Where is the doubling happening?
As I said, there is no doubling. We put again, I can go back where you specify the doubling inside the data mesh and mesh par file. So we use regular mesh here, you see. No, it doesn't matter. If you put true regular mesh, there will be no doubling. So you need to put this parameter to false in order to make the doublings. And then as I specify, you put 1 or 2 and then number of elements in the vertical direction where you want to put the mesh, the doubling. I can explain you how to do it. Yeah. So we generate the mesh, open in Paraview. Everything is fine so far. The mesh looks as what we expect. So, and it's very quick. It's like you put the parameters, 1 second you have the mesh. And instead of going to the qubit for simple model, you definitely at the initial stage it's worth to do this. So you go to representation and you select surface or surface with edges. You can also use.
It's a surface with edges up on the toolbar.
Okay, I'll close you, but you can place Paraview after. Now let's move forward, and the next stage, second step, is generate database. In the same way, there is a script